So there are two types of special right triangles that we're going to talk about. The first one comes from an equilateral triangle. So I'm going to sketch kind of an equilateral triangle. So what do we know about an equilateral triangle? First of all, we know that all three sides are the same length. That's where the name comes from, equilateral, equal sides. But we also know that all three angles are the same measure. And we also know they're measured. 180 divided by, and we know 180 degrees in a triangle, divided by 3 is 60 degrees. So each one of these angles is 60 degrees. So now what I'm going to do is, if we constructed an angle bisector, or even a segment bisector, we end up with this line right here. So what do we know now? Well, we should know that this side of the triangle is equal to this side, or of this perpendicular bisector. And that's what we call it, a perpendicular bisector. It is going to be at a right angle. Also, this angle right here has now been, or this full angle has been cut in half. And this right side of the angle is equal to the left side of the angle. So do we know that measure? Well, we should. We should know that, first of all, this is a right angle. This one is 60 degrees. And if this one has been cut in half, the right side now is 30 degrees. We call this a 30, 60, 90 triangle. Now, the 30, 60, 90 triangle is cool for a couple of reasons. Mostly what we're going to be using it for is trigonometry and leading into the unit circle. But let's say what we know. Now, again, we know that these three sides were equal. What do we know about this side now? Well, it's been cut in half. Therefore, this part of the triangle, how long is this? Hopefully you see that it's going to be half of the original side. So whatever it is, the short leg is half of the hypotenuse. Now remember, hypotenuse is the side opposite the 90-degree angle. So this is going to be half of the hypotenuse, or you can think of it as the hypotenuse is twice as long as the short leg. Now, what is the length of the long leg? Remember, we use the word legs for the two sides that create the 90-degree angle, and then the hypotenuse is what we call the side of the triangle that is opposite that 90 degrees. So the long leg, we don't know what that is. We know that this will be half of the hypotenuse, or the hypotenuse is twice as long as the short leg, but how long is the long leg? Well, let's give it any number. For now, let's give it 1, or the short side, a length of 1 unit, which would make the hypotenuse 2 units. So then what is the long leg? Well, we can use the Pythagorean theorem, right? We remember that the short leg is referred to as A, the long leg B, and the hypotenuse C. So if C squared equals A squared plus B squared, we know that 2 squared is going to equal 1 squared plus, we don't know, squared. Well, this is 4 equals 1 plus b squared. If we subtract 1 from both sides, 3 equals b squared. Now, how do we find the value of b? Well, we square root it, right? So that's how we unsquare, is to square root. So the square root of 3 equals the long leg. More importantly, it is 1 times the square root of 3. Why is that important? Well, that's important because that's how it relates to the short leg. So I want you to be able to take this beyond just this part. If I were to give you some other triangle, let's say I drew this one up, and I told you that that was a right angle and that this was 30 degrees. Is that enough for you to know that this is a 30, 60, 90? Well, there's only a certain number of angles or measure left over, right? 90 and 30 leave 60 left over. So this is a 30, 60, 90. And if I told you that this short leg was 5, would you be able to tell me all 3 sides? Well, I hope that you could see that the long leg, or sorry, the hypotenuse is 10. But what about side B? Well, again, we can go back to c squared equals a squared plus b squared. So in this case, it'd be 10 squared, which will be 100 in a minute, equals 5 squared plus b squared. And that is 100 equals 25 plus b squared. Subtract 25 from both sides, and we get 75 equals b squared. And now when we square root both sides, I can see that 75 is a square root of 3 times 25. Well, I can square root, and that is equal to the square root of 3 times the square root of 25. Well, the square root of 25 is 5. So this is really the square root of 3 times 5. Or we like to put the radical on the end and the whole number in front. We would write this as 5 times the square root of 3. And you see what I was talking about just a minute ago. This 1 times the square root of 3. So now we know that the long leg of a 30, 60, 90 triangle will be whatever the short leg is times the square root of 3. So this is 5 times the square root of 3. And that happens every single time. So if we were to take kind of a generic triangle and label it, I'm going to do that over here. I'm going to squeeze it in. I'm going to have to make it tall and skinny. If this is 90 degrees and this one is 60, of course that only leaves 30 left over. We call this side x, the hypotenuse 2x, and the long leg x times the square root of 3. So that is something that you want to memorize, and you can check it every time if you want to, but memorize that. All right, so that's the 30, 60, 90. Let's go on to our next special right triangle. Now we get our next one from a square. So I'm gonna sketch a square, and what I'm interested in is a diagonal. So what kind of triangle? Now we already know that for a square, all sides are congruent. So I know that this side is equal to this side and that they form at a 90-degree angle. Therefore, my hypotenuse has to be longer than these two as individuals, not together. But again, what is the length of the diagonal? Well, another special right triangle, we're going to figure this out. Let's just say that these sides are a length of 1. So c squared, which in this case we don't know what it is, has to equal 1 squared plus 1 squared. So c squared equals 1 plus 1, c squared equals 2, and when I square root both sides, c equals the square root of 2. More importantly, it is 1 times the square root of 2. And yes, this is the same idea. So let's take another. If I tell you that this is a right angle and that these two sides are congruent, those are marks of congruence, we know that this must be what we call a 45, 45, 90 triangle. That's one thing I did skip over, is we know that since these two angles are also 90 degrees and they were bisected, that this is 45 degrees and this is 45 degrees. Also, we know that because if this leg is equal to this leg, this angle has to be equal to that angle. And if there's 90, 180 minus 90 is 90. And when you cut 90 in half, you have 45 degrees in both. So if I told you that one of these sides was 7. Well, first of all, just by marks of congruence, we know that the other leg is 7. Now, if you want to go through all of it, c squared equals 7 squared plus 7 squared. So c squared equals 49 plus 49. So c squared equals 98. And when I square root both sides, again, 98, I can turn that into the square root of 2 times 49, which equals the square root of 2 times the square root of 49, which equals the square root of 2 times 7. And of course, we turn it around so that and I put c squared. We do not want c squared right there, do we? So I'll just erase it. So c equals 7 times the square root of 2. So we know that this happens every time. So it's always a multiple of that. So there's our second special right triangle. Now I'm going to give you a couple of problems to see if you can actually work. Well, we'll do the easy ones first. So can you find all the side lengths for these two triangles? If you'd like to do it on your own, pause the video. For the green one, I know it's a 30, 60, 90 because there's only 30 degrees left over. I know that the hypotenuse is twice the length of the short leg, which makes the short leg 4.5, because that's half of 9. And I know that the long leg is the short leg times the square root of 3. So 4.5 times the square root of 3. Units, inches, centimeters, whatever it is. Now for the yellow one, this time I don't know that the sides are equal, other than I do know that it's told me this one is a square, or supposed to be a square, which makes it 90 degrees. And this arc has the same number of arcs as this one, which means since these two angles are congruent, it means that the sides opposite them are also congruent. And therefore I can conclude that the other leg is 3.5, which makes the hypotenuse 3.5 times the square root of 2. And if you would like to check that with your math, you may. Now what I want to do is I want to give you the hard side only. I'm going to give you the side that has the square root and see if you can work backward and get the other ones. So I've chosen 6 for both of them, just so you can see how it affects them differently. Again, if you'd like to try it on your own, go ahead and stop the video, try it on your own. Now, what I know is that the short leg is whatever its measure times the square root of 3 that equals this side, the long leg. So then the long leg, I must need to divide it by the square root of 3 to get the short leg. And that logic is correct. So this should be 6 divided by the square root of 3. Now, I'm not allowed to leave a radical in the denominator. That means a square root. So I have to move it to the numerator. The only way this is called rationalizing the denominator. And the way we rationalize the denominator is to multiply by 1. And I'm going to multiply by 1 in the form of root 3 over root 3. Hopefully you can see that this fraction equals 1. So I'm not changing the value. So this equals 6 times the square root of 3 over the square root of 9, right? Because the square root of 3 times the square root of 3 is the square root of 9. Therefore, it is 3. So 6 times the square root of 3 over 3, because that is the square root of 9. Probably I should have written that down over here so I don't run into the other one. 6 times the square root of 3 all over 3. Now, this can be simplified. You can see that 6 is divisible by 3. Now, if I had used 7, this whole thing would be the same, except for it'd be 7 times the square root of 3 over 3, and I'd be done. But since I can simplify the ones on the outside only, you cannot simplify the one underneath. Remember, this represents some irrational number, 1 point something. It isn't 3, even though it looks like it. So therefore, if I divide the top and bottom by 3, I get 2 times the square root of 3. And that is the short side. Now, in order to find the hypotenuse, I simply double that, and that is 4 times the square root of 3. So those are the 3 sides. All right, let's get this out of the way so we can do the blue one. Blue one, it is the same idea. Since we would take either one of these numbers and multiply it by the square root of 2 to get the hypotenuse, we have to divide the hypotenuse by the square root of 2 to get the legs. What's nice here is you find one, you find them both. Although over here it wasn't much just to double it, right? All right, so this one is, both of them are 6 over the square root of 2. But again, I have to rationalize the denominator. I cannot leave it like that. That is an unsimplified fraction. So 6 over the square root of 2, we're going to rationalize the denominator. If you think you can do it without my help, pause the video and try it. We are going to multiply that fraction by the square root of 2 over the square root of 2. So this is going to be 6 times the square root of 2 over the square root of 4, which is 6 times the square root of 2 over 2. Remember, the square root of 4 is 2. Again, I can simplify the integers, 6 and 2, and 6 divided by 2 is 3 times the square root of 2. So both of these sides are 3 times the square root of 2.